Hello everyone, I am Muhaiminul. I will present our paper BIMBA Selective Scan Compression for Long Range Video Question Answering. Recently, we have seen a lot of interest in multimodal large language models. While existing MLLM excels at image and short video understanding long videos are more challenging. In this work, we aim to develop an efficient video MLLM capable of handling hour-long videos for long-range question answering. Long-range video QA is very challenging since model needs to capture fine-grained details in the video along with high-level global properties to correctly answer different types of questions. MLLM usually extract tokens or features from video frames and pass them to the LLM. However, long video yields extensive number of tokens, making direct LLM processing computationally infeasible. Therefore, existing model uses various compression strategies to reduce the number of spatiotemporal tokens. However, these compression techniques have several limitations. Sparse sampling or pooling often misses salient events and fast spatiotemporal dynamics. Convolution-based compression fails to capture long-range dependencies and global context. Self-attention-based compression suffers from quadratic complexity, which makes it computationally infeasible for long inputs. Recently, we have seen several works on long sequence modeling with state space based models. Compared to self attention, state space models have linear computational complexity with sequence length, which makes it very efficient for lengthy inputs. More recently, an improved version of state space models have been proposed called Selective-Scan or MAMBA models, which has more dynamic control over the input sequence. The MAMBA model is capable of selectively propagate or forget information. Motivated by this, in this work, we want to utilize the selective scan for long-range video modeling. Our goal is to compress the lengthy video token sequence into a compact representation by retaining critical information and omitting redundant ones. We propose BIMBA, an efficient model for long-range video question answering. Given a long video input, first we encode each video frames independently using an image encoder and extract patch level features. Then we employ a spatiotemporal token selector which compresses the long video sequence into a compact set of visual queries. Finally, the complex token sequence is passed to the LLM alongside the question to generate the answer. Here we present more details on the spatiotemporal token selector. First, from the input sequence, we initialize a small set of visual queries using an adapting 3D pooling layer. While pooling operation provides a good initialization for the visual queries, it cannot capture fine-grained details. To this end, we utilize selective scan layer to capture fine-grained details and long-range dependencies from the input token sequence. We achieve this by jointly modeling the visual queries with the spatiotemporal tokens as shown in the figure. Finally, the visual queries are passed to the LLM with the question. We propose several improvements of our standard selective scan specifically for long video inputs. First, we propose interleaving visual queries and spatiotemporal tokens at equal intervals to reduce positional bias from standard end appending methods. Second, we adopt a bidirectional selective scan to better capture 2D and 3D spatiotemporal structures, improving over standard selective scan for 1D sequences. We compare BIMBA with state-of-the-art video MLLMs across 7 diverse video question answering benchmark. BIMBA achieves the best performance on all dataset. On EgoSchema, BIMBA achieves 3.54% improvement over LongView, showing superior egocentric video understanding and long context reasoning. On VNBench, BIMBA surpasses Lava Video by 7.11%, excelling at needle in the haystack question in very long videos. On LongVideoBench, Video-MME and MLVU, BIMBA sets new state-of-the-art, demonstrating effectiveness in handling hour-long videos. We compare BIMBA with 4 compression strategies such as vanilla or no compression, pooling, perceiver, and self-attention based compression. Here we show the accuracy as a function of number of input tokens for NextQA and EgoSchema datasets. BIMBA achieves highest accuracy for all settings. Self-attention and vanilla model fails on long sequence due to GPU out of memory. Finally, BIMBA outperforms pooling and perceiver in all settings, demonstrating superior effectiveness. Next, we analyze the computation cost of our model. Left figure shows the GPU memory uses and the right figure shows the runtime as a function of input token. We observe vanilla and self-attention baseline quickly run out of memory as the number of input token is increased. While BIMBA, Perceiver and polling maintain low memory and runtime cost, our method achieves the highest accuracy across all input lengths. Here we show a qualitative example. Our model demonstrates the ability to answer a wide range of video questions such as needle in the haystack, fine-grained details, and high-level global properties of a video. Thank you everyone. Our code and pre-trained models are publicly available in this link.